Here are some more examples of finding the equation of the tangent line using our new derivative rules. So this first one, it is not in polynomial form, so I need to do a little bit of algebraic mumbo jumbo to get it where I want it to be. But before I do that, we need to think about the two things we need to write the equation of a tangent line. We first need what I've been nicknaming the POT, the point of tangency. And the SOT. That's the slope of tangency. So to find the POT, to find the point of tangency, we need to plug in this x value into the original function. So I need to find f of -1. So when I plug in -1 for x, I'll have 2 times -1 minus 1, and then -1 plus 1 squared. That gives me -2 minus 1 is -3. That's 0 squared. So I just end up getting 0. So here's my point of tangency. When x is -1, my y value is 0. Now to be able to take the derivative, which helps us find the slope of tangency, I'm going to need to multiply this out. So let's remember that x plus 1 squared means x plus 1 times x plus 1. Okay, good. So f of x equals 2x minus 1 times, when you distribute that out, you get x times x, which is x squared. You'll have a 1x plus a 1x, that's 2x, plus 1 times 1, which is 1. Distribute here. 2x times x squared is 2x cubed. 2x times 2x is 4x squared. 2x times 1 is 2x. Now distribute the -1. -1 times x squared is -1x squared. Then we'd have -2x, and then we'd have a -1. So when I combine those, I get 2x cubed plus 3x squared. 2x minus 2x is gone, and a -1. So we learned about the polynomial rule, or the power rule. I'm going to multiply. So 2 times 3 is 6. Subtract 1 from the exponent. 2 times 3 is 6. Subtract 1 from the exponent. And the constant goes to 0. Now I can find my slope of tangency by plugging in to f prime. So I'm plugging in that same x value, but this time into the derivative. So -1 squared is 1, so this becomes 6 minus 6, which is 0. So my slope is 0. Cool. So y minus the y value equals the slope times x minus -1. Or that's just y equals 0. Next one. 4 sine theta minus theta, when theta equals pi over 2. So the first thing I need to do is find my point of tangency. So I need to find f of pi over 2. Sine of pi over 2 is just a 1, so this gives me 4 minus pi over 2. That's my point of tangency. When this is my theta, this is the y value. So now let's take this function, equals 4 sine theta minus theta. And when I take the derivative of that, the derivative of sine is cosine. Think of this as a negative x. It would just end up being a negative 1. So now I need to find my slope of tangency. I need to plug in pi over 2 into here. Now the cosine of pi over 2 is 0. So I just end up with negative 1. So my point is going to be y minus the y value, slope x minus the x value. I'm even going to clean that up. That just looks kind of ugly to me. That'd be plus pi over 2 equals negative x plus pi over 2. Those cancel. So you end up with y equals negative x plus 4. Now, this is correct, so you could leave it there. Next one. Point of tangency. And feel free to pause it and try it on your own and then check your answer here in a minute. G of pi is going to be 2 times pi plus 3 cosine pi. Now, that's going to be 2 pi. That's going to be a negative 1. So G of pi is 2 pi minus 3. Now, I need to take the derivative of G. What up, G? So when I take the derivative, think of this like 2x. The derivative would just be 2. The derivative of cosine is negative sine. So this is going to be negative 3 sine theta. Now I can plug in the theta. So G prime of pi is 2 minus 3 sine pi. Well, that's nice because the sine of pi is just 0. So that's just 2. So that would have been better to do that. Y minus the y value equals the slope times x minus the x value. Now we could make that prettier, huh? Distribute. Oops, that's an x. Those will cancel. Y equals 2x minus 3. H of x equals 2x over the square root of x cubed. That's a lovely problem. Well, first, we need to find our point of tangency. That means we need to plug in x equals 2 into our original function. H of 2 equals 2 times 2 over the square root of 2 cubed. Well, that's 4 over the square root of 8. And just to kind of make it look prettier, that's 2 root 2. So I would have 2 over the square root of 2. Now the slope of tangent, see, I'm going to need to rewrite this just a little bit. Well, square root of x cubed is going to give me x to the 3 halves. Well, I'm going to move that up. So that's going to be 2x times x to the negative 3 halves. Remember, that's x to the 1. So that's going to be 2x to the negative 1 half. Now I can use my power rule. So multiply, subtract 1 from the exponent. Well, I've just seen that recently, huh? That's really negative 1 over the square root of x cubed. So to find the slope of tangent, see, I just need to plug in 2 into that. Negative 1 over the square root of 2 cubed, which was 8. Negative 1 over 2 square roots of 2. So for my equation of the line, y minus the y value, the slope, times x minus 2. Now technically that's a perfectly good answer, so I'd leave it. Given the equation of a function, how might you determine the value at which the function has a horizontal tangent? So let's think about that. What does it mean to have a horizontal tangent? So horizontal tangent. So if I have a graph, to get a horizontal tangent, that's going to be right there at the top or maybe at the bottom of a hill. So a function has a horizontal tangent when f prime is 0. So how can we find it? So find f prime and set it equal to 0. Easy enough. First problem, f of x equals x cubed plus x. Love it. This one looks nice. So the first step is to find f prime. So we're going to find f prime of x. So f prime of x equals power rule 3x squared plus 1. I want to set that equal to 0. So that's going to be 3x squared equals negative 1. X squared equals negative 1. Wait a second. If I try to solve that, I get like plus or minus the square root of negative 1/3, which is, that's an imaginary number. So there is no real solution. So what does this mean? It means that we never have a horizontal tangent. And if we think about this graph, x cubed, that's, you know, like that. It never has a horizontal tangent line. So f of x never has a horizontal tangent line. Don't forget that when you're answering these questions, make sure you actually answer the question. So the next one's, at what value of theta does f of theta, theta plus sine theta, have a horizontal tangent on the interval from 0 to 2 pi? So again, first step, easy enough. We are going to find f prime. I'll keep the same color. So f prime is going to be 1. Derivative of sine is cosine. And we're going to set that equal to 0 and solve the equation. So I can subtract 1. So where does cosine equal -1? Well, that's at, round on the circle, that's at -pi. So I would answer the question as saying at theta equals -pi, f of theta has a horizontal tangent.